Broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, everyone. This is Molly Jacobs, and I'm a Senior Research Associate at the University of Massachusetts Lowell in the Lowell Center for Sustainable Production. Welcome to our Alternatives Assessment 101 webinar. We're awaiting for a few dozen more people to arrive, so we're going to stand by for the next 2 minutes, and then we'll get started. So please stand by with us. If you've just arrived, this is Molly Jacobs from the Lowell Center for Sustainable Production. We're going to wait one more minute as additional participants arrive, so please stand by. All right, we'll get started here. Again, this is Molly Jacobs from the Lowell Center for Sustainable Production at the University of Massachusetts Lowell. Welcome. Welcome to our Alternatives Assessment 101 webinar. It's great to have you all here. And I will be facilitating this 75-minute webinar. And some context for today. So just compared to a decade ago, scientific and policy, as well as market and consumer drivers, are really increasing the demands to better identify and adopt alternatives to toxic chemicals of concern. However, removing a chemical of concern from a process or a product without adequate consideration of its replacements could result in shallow or regrettable substitutions or adoption failure because these alternatives simply do not perform as needed. So alternatives assessment has emerged as an important science policy field to guide the product design and substitution decisions. But what is alternatives assessment? So today, we're going to answer that question for you. So again, it's a 75-minute webinar and designed to be an introduction to those that are new to the field. For those attending our International Symposium on Alternatives Assessment next week on November 1st and 2nd, and are, again, new to this field, this webinar will give you the foundations necessary to delve deeper into the topics that will be addressed during that conference. So questions that today's webinar is designed to address are as follows. What is alternatives assessment? Why should we use it? What are its main components? And how does it differ from other aligned fields such as risk assessment or life cycle analysis? We are fortunate to have with us a series of panelists that are practitioners and researchers in the fields, and also to be addressed on this webinar is lessons learned from their experience and what's necessary to really drive the field forward. So a couple of logistics. Due to the number of participants on this webinar, all lines are muted. If you wish to ask a question, and we do encourage them, please type your question in the Q&A box located on your drop-down control panel at the top of the screen. We are going to hold questions until the end, but all questions will be addressed at the end of the presentations. So we'll leave at least about 15 minutes or so for Q&A. This webinar is recorded, and slides along with the recording will be posted to the saferalternatives.org website. And so today I am pleased to have with me my colleagues from the University of Massachusetts Lowell. They will be giving our the primary kind of webinar training, as it were, on alternatives assessment. And so they're going to switch off among them. But my colleague Joel Tickner is a professor of public health at the University of Massachusetts Lowell. He also directs the science policy, the chemicals policy and science initiative at the Lowell Center for Sustainable Production. Payam Eliason is the Senior Associate Director at the Toxic Use Reduction Institute, and she also directs the Institute's training programs. They'll present for about 30 minutes, and then we are fortunate to have with us a panelist of respondents from industry, from academia, from consultancies, as well as from government. And with us on that panel is Dr. Pam Spencer, who's the Senior Director of Regulatory Affairs and Product Stewardship at Angus Chemical, Tim Malloy, who's Professor of Law at UCLA, and at UCLA, he also is the Faculty Director of Sustainable Technology and Policy Program. We have with us Kathy Rudisil, who is a Chemistry Manager in the Environmental Health Analysis Group at SRC Inc. And lastly, we have Meredith Williams, who is the Deputy Director of the California Department of Toxic Substances and Control. So with that, I'm going to turn it over to our main speakers, Joel Tickner and Pam Eliason. Please.
Great. Thank you so much, Molly. So to reiterate what Molly has said, what we're going to do is in the next half an hour, cover the fundamentals of alternatives assessment. We're not going to go into great detail on any particular tool or application, but really start with what I would say a level setting baseline of what is it, how does it work, so that when you think about alternatives assessment, you think about its context and how it differs from traditional chemicals management and assessment tools. So we'll be going through the what is, the principles and main elements of alternatives assessment, some of the scientific literature, policies, applications, and then Pam Eliason is going to talk about a very concrete example, one of the most successful examples out there of how alternatives assessment has been built into both policy and application through the Massachusetts Toxic Use Reduction Program. And then we'll talk about some lessons learned at the end. So let me start with a broad brush overview of what alternatives assessment is. To start at, alternatives assessment is a science policy method basically focused on informing the selection of chemical alternatives and with the goal of supporting the transition to safer chemicals, materials, and products. So it's an action-oriented, solutions-oriented science policy field that is designed to guide the transition to safer, more sustainable chemicals, materials, and products. Now, from our work over the last 20 years, we understand that there are a number of core components, but also some gaps in those components. And that's where we're evolving in terms of the research and policy and practice agenda moving forward. Alternatives assessment supports informed substitution, and that has two parts to it. It has both the assessment part and, as Molly mentioned, the application or the adoption part. And then lastly, as we go through this, is in any new field, there's a tendency to get deep into the weeds and lose sight of the forest from the trees. So when we think about the context of alternatives assessment, the goal is to inform and support the transition to safer chemicals and materials. And we don't want to get into this enemy, perfect is the enemy of the good, that leads to paralysis by analysis, because in the end, decisions are being made about chemical selection, and we want tools that can help effectively inform those choices. So alternatives assessment is, as defined by the National Academy of Sciences, the National Research Council, in its framework to guide the selection of chemical alternatives, what we might call the Green Book of Alternatives Assessment. Risk assessment was defined by the Red Book in 1986. Alternatives assessment has been organized or put into a framework by the Academy in 2014. It's a process for identifying, comparing, and selecting safer alternatives to chemicals of concern on the basis of their hazards, comparative exposure, performance, and economic viability. So the Academy laid this out very clearly of what is the difference between alternatives assessment and other types of assessment. So the starting point of alternatives assessment is a priority chemical or a chemical of concern. And we'll put that in quotes, that the concern may be a scientific concern, a social concern, a policy concern. But the starting point is there is an incentive or a drive to substitute that chemical of concern. So alternatives assessment is a process for comparing and selecting alternatives, and it has that goal of facilitating an informed consideration of the pros and cons, advantages and disadvantages of alternatives. It's not a safety assessment, where the goal is really to ensure that exposure is below a prescribed standard, or a risk assessment where we're trying to calculate the risk associated with a given exposure, or what we might call a sustainability assessment, where we're trying to evaluate all the sustainability aspects of a material, including its contribution to sustainability. So alternatives assessment has a role in parallel with these other tools. Clearly that once a company or chooses a material, makes the selection, they're going to undergo a risk assessment process to make sure that that application is indeed safe. So we're going towards safer rather than getting to safe. EPA has defined a goal of alternatives assessment as informed substitution. This is a very nice definition. It's a considered transition from a chemical of particular concern to safer chemicals or non-chemical alternatives that minimizes the likelihood of unintended consequences that can happen when decisions are made without good information, but it enables a course of action based on the best available information. So it's not waiting for perfect information, but it's enabling a course of action based on the best available information. We know and we've heard about regrettable substitutions where chemical deselection decisions are made without a thoughtful consideration of those alternatives. So often our focus in dealing with chemicals of concern has been just eliminate them, phase them out. But without that consideration of what those alternatives might be, we can get regrettable substitutions that may either be regrettable because the alternatives don't function well, or they shift risks between, for example, consumers or workers, or the environment and workers, and we want to avoid those, and we can by careful planning. So when we get to the focus of alternatives assessment, the focus is, again, it's step defined and action oriented. And our starting point is the function of a chemical, not the particular chemical. So we are, the entry point to alternatives assessment may be a concern about a particular chemical, but we're really focused on how do we achieve that function in a safer and more sustainable way. And by doing that, we can focus then on this intrinsic impact reduction. So how do we reduce both the hazard as well as the exposure characteristics of concern, whether they be persistence or bioaccumulation or vapor pressure, or intrinsic considerations of that molecule that would increase exposure, the migration potential, for example. But it also considers why we're using that chemical or that function. Is that function necessary? Is it overprescribed? For example, we might look at certain uses of hexavalent chromium in plating operations where it was prescribed by a military spec, but that level of protection isn't necessary in all cases of anti-corrosion protection. The other part that we think about in alternatives assessment is, one, you may find a safer alternative, but getting it adopted, will it work in practice, is a very different thing. So alternatives have to be affordable and effective. And in some cases, those alternatives may not exist, in which case they need to be developed. So on the National Academy's framework, there's this off-ramp for green chemistry and safe by design research. So sometimes better alternatives may not necessarily exist, and we really have to do the work to design them and move them forward. So if we take that functional substitution approach as the starting point for alternatives assessment, we can think broader about what our chemical and material and functional options are. And this is a paper we published a couple of years ago that opens up the thinking. If we take, for example, bisphenol A and thermal tape, our alternatives may be a drop-in chemical substitute. They may be a redesign of the chemistry, or they may be a total functional change, which is electronic receipts. It's a different way of thinking about those problems. Mary O'Brien, who will be the keynote at our International Symposium on Alternatives Assessment, which takes place next week, wrote a wonderful book called Making Better Environmental Decisions, where she sort of frames the difference between risk assessment and alternatives assessment, but makes a very clear point that one of the most essential and powerful steps to change is understanding that there are alternatives. And she takes alternatives assessment as a very simple process. Clearly, the implementation is more complex, but the simple steps are, and the Academy talked about this really, it's presenting a wide range of alternatives, looking at the potential adverse effects of those options, and looking at the potential benefits of those options. And there's some guiding principles to underlie that process of alternatives assessment. So a group of nonprofits, government agencies, academics, and industry got together and created what are called the Commons Principles for Alternatives Assessment. And these are the basic underlying values that many of us see underlying the process of alternatives assessment: reducing hazards, minimizing exposure, using the best available information, ensuring transparency through the value chain and in the science, making sure trade-offs are clear and open, and then ultimately the goal of alternatives assessment is taking action. These are the essential basic steps of an alternatives assessment, and we'll talk about the difference in frameworks, but the core steps generally are consistent between alternatives assessment frameworks. This is a paper from 2005 in risk analysis. So the starting point of an alternatives assessment is the scoping phase. So defining your goals, defining the range of chemistries you want to look at, defining the life cycle impacts you might want to look at if those are important in your assessment, or the potential trade-offs that you might have. Doing the actual assessment, identifying alternatives, a wide range of alternatives, an initial screening of those alternatives, comparing the hazards, comparing potential exposure trade-offs and other impacts like life cycle impacts, looking at performance and economics. And then lastly, the third part of that scaffolding is the selection and implementation. We see alternatives assessment as a continuous improvement process. So it's no alternative may work perfectly, so you're always trying to continue to move in a forward direction. Taking those steps in a little bit more detail, scoping is really the scope and the plan, and gathering data. Identifying alternatives is this process of wide-ranging consideration of those alternatives. And we've seen in practice, and Pamela Eisen will talk about this, expanding the number of stakeholders involved in that identification and evaluation helps make that assessment much more robust and broad, and be able to identify potential trade-offs, for example, workers being involved in that assessment process. Hazard assessment is looking at the human health and ecological hazards, exposure characterizations, evaluating the intrinsic exposure potential and potential trade-offs of those. Technology feasibility is key and often not part of assessments. The comparative economic feasibility, taking at least a basic look at that. And then at least life cycle thinking about where there might be some trade-offs within the life cycle of a chemical or material. And then lastly, the process of decision making. How do you pull all that information together to make a robust decision that is open about the potential trade-offs in the choices made? And then lastly, this adoption phase. And if there aren't good alternatives identified, how do we drive research and development of green chemistry solutions? So we did an analysis about 3 years ago of alternatives assessment frameworks, and we identified over 20 alternatives assessment frameworks in the literature. These frameworks are mostly guides and not prescriptive protocols, so it's very important to think about alternatives assessment is not a rigid process. Much like the 4 steps of risk assessment are not a rigid process, but really a context, and that context has to vary by the user. A small and medium-sized company isn't going to be able to do a detailed multi-step, 20-step alternatives assessment. So really thinking about the use and context matters, which means that the frameworks have to be flexible, and adaptive, but consistent and transferable in their approach. Many of the alternatives assessment frameworks have similar elements and even similar criteria for those elements. So there's a lot of overlaps in them. So if we take the next step down is looking at methods and tools, some are more developed than others. And we're not going to go into great detail in those assessment tools. For the comparative hazard assessment, that has the most tools, consultants supporting those tools, and approaches available. Even within the tools of comparative hazard assessment, we understand that data gaps are still a challenge, particularly for mixtures, for certain types of toxicology endpoints. Economic assessment doesn't have really a lot of tools at the business level for doing a comparative economic assessment. Many of those are very academic socioeconomic analysis methods, but those are tougher for smaller companies to implement. And on technical and performance assessment, that tends to be a very individual company effort and very case specific. And then other tools are being developed for life cycle, for comparative exposure consideration, characterization, and decision analysis. But the tools specific to alternatives assessment are still limited, right? So there are plenty of tools out there for exposure assessment. And the question is, how do those apply to the comparative exposure analysis that might take place as part of an alternatives assessment? If you take those a little bit out broadly on the hazard assessment tools, there are a number of different types of tools. There are tools that connect those who have chemical challenges to those who might have solutions. There are restricted and preferred lists. Those tend to be what you want to avoid, but in some cases there are lists of safer chemicals, like the EPA's safer chemical ingredient list. There are chemical hazard assessment screening tools. These tend to be rapid screening type things based on lists, authoritative lists. And then there are comparative assessment tools like the green screen or the column model in Europe. And then lastly, there are data tools, tools that actually have access to toxicological data that may or may not be in a hazard form, for example, a globally harmonized system type classification. These are all collected in a great resource, which is the Organization for Economic Cooperation and Development's OECD Substitution and Alternatives Assessment Toolkit. That is online, and you can search types of tools by what your needs are. The last issue here is, how do we move from the gaps into developing a research agenda to fill those gaps? So our last International Symposium on Alternatives Assessment back in 2015 really focused on where are the research needs for alternatives assessment, and out of that symposium we established a set of discussion groups looking at different elements of alternatives assessment, different components, and really understanding where the gaps are and what the research needs are for each of those gaps in the research agenda for alternatives assessment. This is a paper that has just been published in Integrated Environmental Assessment and Management, which is the result of those 3 years of work. Just to give you an idea here, where some of the research needs are for alternatives assessment in the science moving forward. For hazard assessment, it's really improving approaches for certain toxicological endpoints like ecotoxicology, being able to integrate multiple data types from in silico to in vitro to in vivo to high throughput methods. And how do you address uncertainty in assessments? Establishing approaches for mixtures and chemical to material comparisons. For the comparative exposure assessment, really how do the results from that assessment get integrated with hazard assessments to identify trade-offs in an alternatives assessment? For life cycle assessment, how do we streamline those needs at the scoping phase and the problem formulation phase of alternatives assessment, and then target those life cycle stages and impact categories that are most important, significant, so that this doesn't become such a huge investment of analysis that you can't actually make a choice. For decision analysis, it's really how do we develop those tools to make more deliberative, thoughtful decisions, bringing together multiple attributes. And then lastly, important is professional practice. What is best practice here in alternatives assessment, and how do we enhance the professional capacity for alternatives assessment through training and education? So lastly, alternatives assessment and policy. There's been sporadic use of alternatives assessment and policy, and we've done a couple of analyses of these, and we might sort of put it into two bins. One bin is regulatory policies, and the others are non-regulatory policies. So if you look at innovation literature, alternatives assessment, if you think about substitution and innovation, you need both willingness and capacity. So you have regulations or other market-based drivers that push that willingness to substitute, but then you need capacity. You need actually incentives, you need support, you need training and education to support that substitution process. Again, alternatives assessment is the process of evaluating alternatives, and informed substitution is the actual ultimate adoption of those alternatives. So regulatory policies in the literature are those that require alternatives assessment to demonstrate the availability or lack of safe or feasible alternatives. So you could take REACH, the authorization requirements, or the California Safer Consumer Product regulations that Meredith will be talking about. Requiring alternatives assessment to support regulatory actions. This is happening in the state of Washington right now. Integrating safer alternatives into procurement processes. The city of San Francisco has been doing this, and we've seen this in some actually standards like electronic standards right now. Requiring facility planning. Pam will be talking about the Massachusetts Toxic Use Reduction Program. And then classification-based substitution. So in Europe, for example, occupational health standards that require that carcinogens be substituted with safer alternatives. Then non-regulatory type policies are those that where an agency conducts assessments of alternatives for priority chemicals, or they provide technical support, demonstration, networking, and training, or agencies provide data, positive listing and labeling, like the EPA Safer Choice Program. And what we've seen is that policy has to be a mixture. Strong policy for driving informed substitution and supporting alternatives assessment is a mixture of both regulatory and non-regulatory policies are most effective. So with that, I'm going to pass to my colleague Pam Eliason, and you should be able to take control of the slides. So thank you, Pam.
Thanks, Joel, and hi, everybody. So Joel did a great job of just sort of setting that context, and there's so much to it. In Massachusetts, we've had the toxic use reduction program in place since 1989. And the requirement in Massachusetts is that if you are a large quantity toxic chemical user, you need to report on your emissions, just like anywhere else in the United States, but also report on how you use a chemical, and then every other year go through a process of really looking at why are we using that chemical, and do we have opportunities to reduce that use. And essentially the process of toxic use reduction is in fact alternatives assessment, and we've been doing it for close to 30 years now, and it's been quite effective. The Toxic Use Reduction Institute, where I work, is really here to support companies in being successful in reducing their use of toxic chemicals, and we do it in a number of ways. And we're really focused on promoting adoption of safer alternatives. So what we do as we look at what our priorities are, is we look at what are the main, the highest quantity used chemicals in Massachusetts, and we have that data. And then we prioritize those that are considered to be higher hazard substances. We provide tools and training to help the professionals who are responsible for assuring that toxic use reduction or alternatives assessment is done in good faith, assuring that they have all the tools and techniques and latest information on hazards available to them so that they can make those assessments in good faith. We also do assessments at the Institute to to look at chemicals that maybe individual companies are not looking at quite so closely. And then finally, Joel's talked about the need to develop alternatives when none exist, and we provide research funding to help support that activity in Massachusetts. All right, there we go. So I want to just quickly talk about some of the tools that we use here in Massachusetts. And these tools are really about identifying options, gathering the information needed to make an assessment, and then doing a comparison of options. So let's see, there we go. The first I want to just quickly talk about is cleanersolutions.org, and this is something that was derived by the cleaning laboratory here at Turry. To help companies identify alternatives to the various industrial parts cleaners that they use. It's a database with over, it's close to 20,000 different data points. And what you can do is you can find alternatives through a number of different sources. I'll just show you quickly. One of the ways to do it is to look at finding a cleaner. And here you can see what you can do is you can identify what the contaminant that you're dealing with is, on what substrate, and if applicable, if there's specific equipment that you want to limit your alternative search for. And plugging in that information, you will get a number of hits from the database that will tell you whether or not they've been demonstrated to be to perform for that specific application, and a relative assessment of the hazards associated with the alternatives. Because we're focused on safer solutions, the alternatives that are being tested are typically far safer than more traditional industrial cleaners. Oops, I'm going the wrong way, sorry. Here we go. So another tool that was developed in Massachusetts, and Joel, was a big part of this originally, was the development of the Pollution Prevention Options Assessment System, or P2OASIS, which for decades was an Excel spreadsheet-based tool. It is now being converted into a web-based tool, and it's really quite useful and I think fairly user-friendly. And what you do is you can identify the different alternative products that you want to look at and put in the data either from your safety data sheet or just from your own research and finding data on different products. And I say products because it's not just a chemical comparative tool. It can really give you deeper information about the product characteristics, and also in P2OASIS it looks at process characteristics and life cycle characteristics, not in quite as much depth, but they're there. What it requires is that the user take advantage of their own professional judgment in determining how to assess different products. We have a webinar available on our website that you can see at the bottom of the screen there, and you're welcome to go look at that, and I'm happy to give you more information, but let me just move on and talk about some of the work that we've done in Massachusetts. The cleaning laboratory has been working with facilities across New England, really, to help in reducing the use of higher hazard substances that were once upon a time quite commonly used in industrial parts cleaning. So trichloroethylene is the obvious example of that. And you can see that through the work of the industries in Massachusetts, as well as the very concerted effort of the laboratory to assist in finding safer alternatives, Massachusetts companies have significantly reduced their use of trichloroethylene across the board, and really quite impressive. Another higher hazard substance that we focus on is perchloroethylene. So again, another chlorinated solvent that is used in a number of different ways. We focused our work on looking at dry cleaning options, partially because the other uses were already being evaluated elsewhere, but also because dry cleaners tend to be fairly small operations with not a lot of resources to do this kind of work. So we really wanted to work with dry cleaners to help them look at what alternatives might be available. We identified a number of different alternatives that were on the market, and we assessed them. The color coding is associated with that chemical hazard assessment, but we also looked at the worker health issues, we looked at the financial issues, and we looked at technical and performance criteria and compared all of those things, creating a table that you see here, not well, but that gives the information but doesn't necessarily make a judgment. The color coding judgment that you see there is really only based upon the chemical hazard associated with the different alternatives. Another example of this kind of, oh, I'm sorry, before I do that, I just, we kind of followed up that assessment work by really working with cleaners to help them make the switch from using PERC dry cleaning processes to dedicated wet cleaning, professional wet cleaning. And I think we have more like 20 dedicated wet cleaners in Massachusetts now, but we've done a lot of work to help support them in making the switch. Another example of the work that we've done here at Terry is looking at the use of hexavalent chromium, and Joel mentioned that earlier. It's used in a number of different ways. We focused again on the metal processing and plating applications that are associated with the corrosion resistance function of the hexavalent chromium. And what we did in this case is we focused on a very specific application, aerospace and defense applications, and we focused in on this because in 2011 there was a new kind of a stipulation associated with defense contractors that they had to start moving away from hexavalent chromium for the primers and sealants used on a variety of applications. So what we did is we gathered a group of industries across the whole supply chain to work together on establishing a testing protocol for alternatives, identifying what alternatives might work, and then doing the testing, analyzing the testing with statistical analysis, and then moving towards adoption. It's really been a fascinating process that's been going on for many years now, and we have been really able to help the whole supply chain move away from the use of hexavalent chromium. And in these very high reliability critical applications, this kind of industry collaborative performance testing approach is essential to giving the users the confidence that they can move forward safely. So again, in Massachusetts, what we do is we identify where the significant use of toxics are happening, and we focus on applications where currently no safer alternatives might be available. We look at whether or not the industry sector has the capacity to do this work themselves, and then these factors we use to help us guide our approach towards trying to fill in those data gaps. One of the ways that we do this is through our academic research program, where we can identify the lack of a functional, safer alternative for a specific application, and we can fund faculty to try to do some research to develop an alternative. I'll just very quickly show you one example, and this is the use of octyl phenol ethoxylates in medical devices as a surfactant in a laboratory equipment. Common surfactant used in these immunoassay products. It clearly needed to be eliminated in response to restrictions coming from the European Union. So we funded research at a very affordable level to try to identify an alternative to the octyl phenol ethoxylates. And what we were able to do is come up with something that has functioned, and the company is currently working on scaling up the production and processing of this new alternative. So in Massachusetts, what we do is we focus on the high hazard and high volume uses of chemicals. We look at performance, hazard, and cost, and those three elements of an alternative are really what are needed to be understood in order to get a company to be able to adopt an alternative. And then we develop information that is appropriate for the audience that we're talking to. And so what we've learned is that you can really, really can take action based on not having full comprehensive information, but by identifying your priorities, doing your research, you can identify ways to move forward. And then, we're just really focused on trying to disseminate that information as broadly as we can. So Joel, I'll give it back to you.
Thank you, Pam. So just to wrap up the beginning, and then we'll switch to our commentators. Alternatives assessment is quickly becoming a field of science and practice, and while there's been an amazing evolution in this field in the last 5 to 10 years, an explosion in the field of alternatives assessment. Much of that is driven by increasing demands for safe and sustainable chemistries. There are still gaps, which is really why we need to build a more coherent, coordinated community of practice to ensure that this science moves in a positive direction. There are a mix of regulatory and non-regulatory tools, policy tools is needed to support this transition to safer chemicals. And always to remember that it is action-oriented. And to avoid paralysis by analysis, as in the National Environmental Policy Act talks about it with regards to environmental impact statements, the goal is excellent action, not excellent paperwork. So keeping alternatives assessment flexible, iterative, growing, and adaptable to different decision contexts is key. And then lastly, this focus on both assessment and the ultimate goal, which is really informed substitution or adoption of those alternatives and growth of those alternatives. With that, we have in the webinar, and we'll be having those in our slides on the website, a number of really useful tools for and resources for alternatives assessment. The OECD toolkit, OSHA has a very nice and simplified website to walk small and medium-sized companies through the process of alternatives assessment and resources to support that. The Toxic Use Reduction Institute, the Interstate Chemicals Clearinghouse. In Europe, there's the Subsport Project, Clean Production Action, a nonprofit, has a number of tools, and a very nice new effort that came out of the Chemicals Common Principles is the Chemical Commons, a searchable chemical hazard database. Just a reminder, if you just happen to be in Sacramento next week, the International Symposium on Alternatives Assessment is taking place next Thursday and Friday in Sacramento. And with that, thank you, and I'll pass to Molly.
Thank you. Thank you, Joel, and thank you, Pam. I know each of you have spent time conducting these trainings over the course of a whole day, and to shrink this down into 40 minutes is a bit of a task. So thank you for this overview, and Joel and Pam, kind of the direct experience from Turi. Again, I know there's a lot of content here, so for participants listening in, I encourage you to ask questions post your questions of Joel and Pam as we turn to our panel. Again, we asked a panel to come together to really reflect from their role in industry and academia, in private consulting, and in government about the utility of alternatives assessment to support informed substitution efforts, and what they see from their position as kind of needs and opportunities to move forward in building this field together. And so with that, I want to introduce our first panelist, Pam Spencer. Again, Pam is the Senior Director of Regulatory and Product Stewardship at Angus Chemical, and we're really fortunate to have Pam provide so much leadership in this field within the industry. So Pam, let me turn over and let's hear your reflections on the past presentations, but just also your direct experience.
Great, thanks Molly, and thanks Joel and Pam for the great overview. It's really exciting to see the collaboration, Pam, that you're showing between product developers and working together to do that kind of innovation. I think that's really, from my perspective, the real value of looking at alternatives assessment as a more, I would say, developed and evolving science that we can apply. And I don't know, Molly, I think I gave you a slide, but if we could show that. I just want to highlight, as a company who's developing new products, alternative assessments are becoming incredibly important. And it's not just the science of alternative assessment, but it's the science of toxicology that these things are developing in a pattern now where we can actually start to look at alternative assessments in a little bit different framework. And I think as we look at alternative assessments, historically, they focused on making comparisons and substitution for existing products. And that's because that's really, where the focus has been. But the way the science is evolving today now, we can really start to think of a vision where alternative assessments is something that supports innovation and can actually inform the design of safer alternatives, not just the comparison. And I show this little diagram or schematic because this is what we call the stage gate process, and it's a process that we use in industry to determine what products are going to advance into the development cycle and ultimately into production and into launch. And historically, we have not been able to bring the safety assessment into that process till very late in the stage gate process. And by that time, you can imagine that companies have invested a lot of time, energy, and resources. So when we get a material that's to that level and we find an issue with product safety, it becomes very difficult to redirect. We've invested so much time, we don't have a lot of choices at that point. So I liked what Joel said about the fact that alternatives assessments is flexible, iterative, and adaptable, because that's exactly what industry needs as they're looking at the development of new products. So now we can start to apply alternatives assessment at the very early stages of product ideation, before we've even made it, because of the way that our tools are developing on the science end of the safety assessment spectrum. We can start to get very early information on safety profiles of materials or candidates before we even go to the bench and make them. And that's very informative, because as we use that and we're using alternatives assessment very early on to compare potential new candidates, as we advance those based on those early screening assessments, we can have a higher probability that the chemistry or the product that we're going to launch is going to be sustainable and really fulfill the need of being truly a safer product. So I think it's really important to not just think about tools and things that we're using on the back end, but as a community of practice, how do we really build the vision that we can use this to design for safety? And that's really an exciting, I think, aspect of this. There are going to be challenges. I'm not going to say that that's going to be easy. I think, internally, some of the challenges that we face are just breaking down silos where we can learn to work together across our multidisciplinary areas, R&D chemists, safety, scientists, marketing and commercial people. We really all have to come together and work, and we have to be able to create product development teams that not only understand health and safety outcomes, but that those outcomes can truly be associated with design or redesign choices, and how do we, maximize that opportunity. And then safety scientists really have to get some general understanding about, what are the tools and how do we apply them at what stages of product development, so that the tools we're using match the stage of product development that we're in. And that's an important area as the field of alternative assessments is looking at, to say, okay, how do we match tools to the product development stage? If we look at cross-sector, I think, and Pam, you highlighted this, partnerships are going to become incredibly important. No one discipline can do this on their own, and so we have to start to build a culture that not only encourages innovation but understanding of what is needed. And I think you've identified performance, hazard, and cost, and those are certainly three big areas that as a company that's looking at developing new products and innovating, and where we have opportunities to replace products that have potential concern. Those are key areas. But I think more importantly is that we have to ensure that whatever we're doing, that the models are scalable and transferable. And what I mean is that whatever we're doing can work not just for large companies or for regulatory agencies, but for small companies that are starting to look at new product development. And again, Pam, I'll just point to your example because I love that you're partnering with academia to really try to target areas where innovation is needed and to bring in those industry perspectives to help, guide that product development. And finally, I'll just leave you with that we really do need a forum for open knowledge sharing. I think it's happening kind of loosely today, and we really have to have a community where we can start to have regular sharing about lessons learned. How do we avoid repeating the same mistakes? How do we develop those best practices? And how do we inform training and education needs? Because those are certainly things that we're going to have to look towards with an eye of what's going to be needed in skills and training in the future. Because certainly as an industry, we know that the way that we're developing and taking new products to market is changing. So with that, I just want to thank you for the opportunity to share those comments and to say that I'm really looking forward to, how this field is going to progress and where it's going to lead us, because I think it has an important role as we look at sustainability of our new products that we're putting on the market.
Thank you, Pam. Really insightful, and thank you for just sitting back and reflecting, and also I think just raising not just the substitution context for alternatives assessment, but as your remarks began, really the opportunity to think about the tools for alternatives assessment in the design and the development stage of new products. I think that's a really critical edge that alternatives assessment is moving into. So thank you for that. I want to turn to Timothy Malloy, who's a professor at law at UCLA, and asked him, your reflections from academia about the utility of alternatives assessment, what you see as kind of the needs, challenges, and opportunities going forward. Tim.
Yes, thank you. I wanted to first off thank everyone for putting together. This is a terrific webinar. And a lot of the work that I do focuses on decision making in the context of alternatives analysis or alternatives assessment. I guess in the few minutes that I have, I'll focus on just a few types of questions that often come up. So the first question is, so what kind of decisions are we talking about? If you were able to see the graphic from the National Academy of Sciences report, you would have noticed that there were several decision points in the alternatives analysis framework there. There's two in particular that I think can be most challenging. One is the step in which you identify and prioritize the alternatives that you're going to consider. In many situations, there's a wide range of possible alternatives, but most people don't have the time or the resources to look at every possibility, so there's a need to prioritize a bit and then go collect the information that is available on a smaller set of alternatives. The other decision that's often challenging is actually choosing among that smaller set of prioritized alternatives after you've had a chance to collect the information that exists and structure it in a way that allows you to make some comparisons. So those are the two types of decisions that I think oftentimes raise the most challenges. Now, you might then ask yourself, well, how do folks deal with those kinds of decision issues now in real life? While alternatives analysis is an emerging methodology, as Pam pointed out, in some circumstances, people have been making decisions like this for decades. So what have we learned from how people actually deal with these decisions? And some of the work we've done, we've brought folks from industry and government and NGOs in and had them run through simulations and asked them, how did you make your decision? And the answer here is it's pretty variable. Experienced folks use a variety of different approaches. Some are what we might describe as holistic. They don't have a formal structured approach, but more they're guided by their experience and intuition. Other folks use more structured methods, such as decision rules or perhaps a decision tree. And then others use even more systematic approaches, something akin to what we might describe as formal decision analysis. So there's a lot of variability across individuals and across sectors. So it's difficult to kind of make any kind of generalization about the specific ways in which people make these sorts of decisions. Which leads to the next question, to what extent can tools help with the decisions that come up in alternatives analysis? So some of the prior speakers have described for you a wide range of different tools for helping with hazard characterization, tools that help with exposure. And these are all play different roles in the context of alternatives analysis. How about a tool for helping you make the trade-offs, evaluating the trade-offs and selecting a final alternative? In some cases, the decision will be fairly obvious. In other cases, it will be very, very challenging because in some circumstances, one alternative may give you much better performance in say, human health criteria that you care very deeply about, but fairly bad performance in terms of ecological impact. So how do you manage those kind of trade-offs? How do you make those kinds of decisions? There's a variety of tools, some very simple and some very complicated, even using various software platforms. I think the key here is to think about what your decision needs are and not get too wrapped up in the what appears to be the really sophisticated nature or unsophisticated nature of a particular tool. And for me, it helps to ask, what are the ways in which we think decision analysis tools can help us in our decision making? And there's 4 things in particular that research has shown that these tools may help you with. One, these tools, by forcing you to systematize the way you're thinking about a decision, can help you to understand in more explicit terms what your actual goals and values are. Oftentimes when we make decisions, these things, our goals and values, tend to be in the background and we don't articulate them explicitly. The other thing these tools can help with is structuring the information in the most useful way. It may be use of various visual or graphic interfaces. It may be by asking questions in a particular order. But the idea is to take vast amounts of information and put them into usable forms to help detect patterns or other ways of minimizing the amount of resource you spent on trying to grapple with the information. Decision analysis can also help you understand the relative trade-offs that are facing you. So there are some tools available that actually explicitly push you to identify how much weight, relative weight, you put on one type of decision attribute versus another. How, when faced with a decision between ecological impacts and human health impacts or environmental impacts versus economic or others, in that particular decision context, what is the relative importance of those attributes to you? And then lastly, these decision tools can help you deliberate. What's important to note here is that we shouldn't fall into the trap of thinking that decision analysis tools, whether it's a simple framework or a sophisticated piece of software, these tools shouldn't become a straitjacket or a black box that hijack the decision, but rather we need to keep in mind that they're merely meant to assist the decision maker, and that decision maker is a human being or a group of human beings. And The deliberation by that individual or group is what is most important. And then I guess the last question is, how do we know that we've got a good decision-making approach or a good decision-making tool? There's a fair amount of work that's been done both in the business management area and the engineering area that has attempted to distill out what are the marks of good decision-making. And these, of course, vary by context. A decision-making tool used in a regulatory setting, such as the California Safe Consumer Products Program, might be very different than the set of the mark of good decision-making in a private setting, right? So we have to keep the context in mind, but generally speaking, there are at least 4 elements that are very important in selecting our decision-making approach or tool. One, the tool ought to be rigorous. That is, it needs to be grounded in science, including decision science, and have well-articulated standards and methodology. Second, it ought to be transparent. That is, the method should be able, it should be set up so that interested persons can have access to the methods and information and the data and understand how it was used. And speaking of use, it's very important that your decision-making tool be usable. It can't be so complex or so resource intensive that it gets in the way of actually making the decision. And then lastly, it ought to be reliable. And by reliable, I mean it ought to offer both consistency across similar cases and impartiality. That is, the decision tool or framework should not drive the decision. It should just assist in the decision. So thank you for giving me the time to talk about a topic that's very interesting to me and I think important to the science and practice of alternatives analysis.
And thank you, Tim. Your research and operationalizing the theory of decision making into actual practical tools that we can use in this field is immensely important. Our previous speakers have really emphasized the action orientation of alternatives assessment. It all comes down to decisions. So this is a really important element of the alternatives assessment practice. I want to now turn to Kathy Rudisill and get her perspective. As an individual who works in private industry, often works on behalf of industry to carry out alternatives assessments and hazard assessments in particular. So Kathy, reflections, and if you could try to keep your remarks to about 5 minutes or so.
Yeah, sure, no problem. Thank you. Yeah, thank you, Molly, Joel, and Pam, and all the panelists. This is, I think, a really great overview session. So I just wanted to clarify what Molly said. I'm actually in the area of contracting and consulting, primarily with government organizations, although we do some consulting with commercial entities. And basically here at SRC, we have a team of chemists and toxicologists who are active in the areas of risk assessment, hazard assessment, and alternatives assessment. And we've supported some various projects, including things like the DFE alternative assessment. And I am actually very active for the past 6 years or so with the Safer Choice program and helping them to expand and maintain a safer chemical ingredient list, and also any of the work involved in supporting the Safer Choice labeling program. So there's a couple points that I just wanted to kind of point out and highlight from the previous speakers in regards to alternative assessment and some of the challenges and important areas that we should kind of focus on moving forward. One of the points that really spoke to me was this idea of incorporating best available science into these assessments. And as focusing on the area of hazard assessment, we know that data gaps continue to be a challenge. So we often have to use other methods, other methods like estimation models or analog approaches, therefore, in other areas like that. I think it's one important thing to think about is that, knowing that as you're doing an alternative assessment, your best available science might be modeled data, and that might be what you have, and then you have to kind of keep that in mind as you're running that through the decision-making process. That being said, I think there are some opportunities, particularly in the area of predictive toxicology, that we can start incorporating new approach methodologies. And I think the field of alternative assessment is kind of in a really good position to start incorporating these new methods, like the new in vitro test methods, or using things like the new approach methodologies or high throughput screening data, particularly in areas where you're operating an alternative assessment that's not necessarily working under a regulatory framework that has very prescriptive requirements for data. So yeah, just the best available sciences might not necessarily be what you're used to seeing under a traditional hazard assessment or risk assessment. Some of the other areas I think are continuing challenge, I think for us and our perspective, is the whole mixtures and variable substances, particularly the naturally occurring substances or the natural derivatives. It seems like a very simple question, but we often get challenged by the very basic question of what is it that we are assessing. And if you don't know what it is you're looking at, and because hazard and safety can be so in line with the actual structure or actual component of what your substance is, you can't really conduct a really good alternative assessment if you don't really know what it is that you're assessing. So just having a better understanding or characterization of things like mixtures and variable substances is incredibly important. And as far as one thing that Pam Spencer noted in her panel discussion was this idea of not working in silos. And I feel like we have, we've had a similar experience that traditionally when we've done the more traditional like IRIS assessments or, the traditional risk assessment, we used to operate very separately from the chemistry versus the toxicology side of it. And as we've been working more and more in the area of safer chemical alternatives, we found that there's definitely advantages to kind of breaking those barriers down and having a lot more collaboration involved. And part of that is because of the whole data gap issue, but I also feel like there are other areas where having that interdisciplinary approach has been very advantageous. So that, this whole field, I think, is really one of the aspects, the hallmarks of this field is the multidisciplinary, multi-stakeholder involvement approach. Is that you can't really just put an AA on someone's desk and say, here, you do this. It really is going to require input from a lot of different areas and a lot of different expertise, and not just people within your organization, but people from outside your organization as well. And let's see, I think that's it for now. So thank you so much for calling into the webinar and letting me have the opportunity to throw out some information.
Great information at that too, Kathy. Thank you so much. Lastly, I'm going to turn it over to Meredith Williams, Deputy Director of the California Department of Toxic Substances Control. So Meredith, your perspectives.
Thank you, Molly, and thanks to all the panelists. I've really enjoyed hearing the different perspectives. And despite the range of perspectives, there certainly are some common themes, starting with Kathy's mention, returning to the idea of collaboration and how important that can be to bringing together different perspectives, the different disciplines. And this is something we anticipated in California. We actually have structured it into our regulations in that we allow companies to work together to perform alternatives assessments, as well as provide for a public process so that the public and stakeholders can review the alternatives analyses and comment on them and hopefully strengthen them. So that collaboration is a very good starting point for people to think about. One of the other themes I heard everybody allude to, and I think was pretty obvious from Pam and Joel's presentation, is we're talking about a lot of complexity. We're asking people who do alternatives assessment to wrestle with the performance, the hazard, the cost, but also exposure considerations and life cycle considerations. And that can be quite overwhelming. Yet, again, the idea is to move to action and move to that action even in the face of data gaps. So I just want to reiterate and underscore this idea of starting where you are. If someone wants to start performing alternatives assessments, look at existing processes, whether that's a product development process, a stage gate process, or whatever. There's, maybe they have a lot of expertise in risk assessment, and try to figure out how to adapt the existing tools and expertise to the needs for a given alternatives assessment, and then try to pick the additional tools that are already available out there to and bring those to bear on a given alternatives assessment. So I think people, again, could get paralyzed to even start this process, but I think there are a lot of ways to start it. It does perhaps take some creativity, but I think, again, in order to manage the complexity, not only do you start where you are, but you also focus on what's really important. And Tim talked about the decision-making process and the fact that there are certain elements of an alternative assessment that are going to be differentiators, that are going to drive the decision more strongly than other aspects. And that perhaps is one place where an entity can decide to put more focus in order to jumpstart the process of alternatives assessment. So why go through all of this? Why take this on, given the complexity, given the fact that it requires so many disciplines? I would say that, number one, it's here, it's happening. Consumers are demanding it. They're demanding safer products. We're starting to see more and more reports come out about the cost of toxics. Just recently, there was a report on the fact that eating organic food, for instance, seems to have a benefit for reducing cancer risk. And that can be tied back to potentially to the toxics that are residual in non-organic foods. But this is just one of several studies, air pollution studies that are coming out that say what cost we are bearing as a society for being exposed to different air toxics. So this is something that we're going to have to wrestle with societally in our manufacturing sectors, in product development. And there are some industry leaders who have already shown that not only can you wrestle with it, you can turn it into a benefit. It can become a product differentiator. It can become a benefit as consumers begin to have more confidence in the products that they purchase. So I do think there's an opportunity here. I do think there's a lot of momentum in the field of alternatives assessment. The practitioners are coming together more and more frequently. The tools are developing rapidly. And so I think there's cause to be very optimistic about where this is going. And hopefully this conversation is the beginning of, or in some cases, the continuation. But for folks who may not have been involved so as much in the past, I think hopefully it's the beginning of real engagement in this process and really starting to leverage all this energy and the tools that are out there to help people do their alternatives assessments. So with that, I'll say thank you and turn it back to Molly and Joel and wrap up.
Fantastic, Meredith. Thank you so much. So we have just a few minutes left before the official end of this webinar. We might extend the Q&A by a few minutes if you wanted to stay on, but we have one question here from our participants, and the question is, how could alternatives assessments be used to identify corporate target chemicals lists and their constituents? And let me pose that question to you, Joel. Joel, I know in one of your slides, for example, you provided a landscape of tools, and in that, for example, were restricted substance lists. And can you maybe speak to the role of those types of target chemicals lists or restriction substance lists and how they play into the utility in an alternatives assessment?
Sure. I think that this is really at the prioritization phase, right, where you're identifying the chemicals that you're looking for alternatives for, and also the screening of the ones you may want to avoid because they're on a target list, because they're subject to a regulatory restriction, they are on a particular hazard list. So that's the sort of initial screen of just saying, well, what should we be avoiding? And you might extend that screen to include structurally similar chemicals. So there are tools like ChemSec in Sweden has a tool called similarity, which will take chemicals and look at their structural similar analogs and say, well, these ones might be ones you want to also look at, avoid as you're looking at alternatives. So really this is about a prioritization process, so then you can narrow down, because in the end, having hundreds and hundreds of options is probably not an easy way to start your assessment. So you've got to start broad and then continuously narrow down what you're looking for. And as we talked about at the beginning, starting with something that's structurally similar may actually lead to a regrettable substitution.
Mm-hmm. Great, thank you. Several of our panelists, spoke of the issue of silos. They spoke of, how the alternatives assessment field is really multidisciplinary in nature. Pam Spencer mentioned that no one discipline can do this alone. Pam Eliason, I'm wondering, given that you often train individuals within small and medium-sized enterprises on alternatives assessment, on informed substitution, how do you break this down for them in a way that, if it's a small team or even a single individual within a company that carries kind of the chemicals management responsibility or the sustainability responsibility, how can they move forward in using these tools to guide their business decisions?
Yeah, thanks, Molly. So, I really think that one of the key questions that we invite people to ask is why. Why are we using this chemical? What is its function? Why are we using it? And just by asking that question, you begin to get a better sense of who else you need to speak with, what else you need to know. And I think that really helps in defining the process. So so we just try to guide our stakeholders and the companies in Massachusetts in really looking at the why for their use of a toxic chemical. And that's all I have all of a sudden.
That works, especially given our time. Well, we are a minute over, and I want to go down the line and ask just final remarks from our six great speakers and panelists, and ask you to help us end this webinar by just getting your reflections on, knowing that many of those that are participating in this webinar are new to this field. How can they get involved? How can they engage? How can we bring them into the fold? What's kind of the first step that you would recommend? Joel, let me start with you.
Well, I think the first is creating a space for this multidisciplinary collaboration focused specifically on alternatives assessment. And one thing we will be doing next week is launching a new professional society for the field of alternatives assessment at the International Symposium. So really building a field, but making it more than just the methods and the theory, but really focused on the practice.
Practice as well. Great. Pamela Eliason, your thoughts?
Just really quickly, I think it's important to recognize that demanding a specific action tends not to be really constructive. So partnering with the people that you are trying to guide towards safer solutions, safer options is really important, and being there to provide assistance in whatever way you can. In Surrey, we're really fortunate that we're able to fund research. Not everybody is in that position, but really finding effective ways to partner with stakeholders so that they feel like they are owning the process moving forward.
Perfect. Thank you. Pam Spencer, please, your final remarks.
I would just say, get out of your comfort zone. Get out there and ask the question again, and it's the why question. As a toxicologist, I look at things from a hazard risk assessment, but trying to understand, what are the things that are driving the chemist's choice? What are the things that are driving the choice in the marketplace? Really what you want to do is understand that, because that's when you're going to find the sweet spot of where you want to go with the, substitution or replacement that you're trying to innovate towards. So.
Thank you. Tim. please. And you might be muted.
Oh, sorry. I can't, I don't think I could say it any better than what the prior folks have just said, so I'll pass.
Fantastic. Kathy Rudisil, any last remarks about bringing new people in and the best way for them to engage?
Well, all I'm going to say is that I know if you're new to the field, it might seem overwhelming, and that there might, with all the resources that were discussed today, it might seem like there's a paradox of choice happening where you might feel overwhelmed. Just know that you're not alone. This is a really great field of really helpful and amazing professionals, and just I would say reach out, start somewhere, someone who's willing to help, and and then that's just the way to go. Just start somewhere, start small, and it'll progress.
Perfect. And Meredith, you have the last word.
Oh goodness. Well, I just say dive in. Dive in by reaching out to people who've already been practicing, or explore one of the toolkits out there, be that the IC2 tools or the OECD tools, or dive in by coming to our conference next week and getting a better, broader overview of all that's going on in the field.
Fantastic. And with that, next week, I do want to just give a final plug for this International Symposium on Alternatives Assessment. There is still space available, but not many. So please register. And as Joel inferred, as did Meredith, we will be launching a new professional association. So it'd be great for you to be a part of that launch, the Association for the Advancement of Alternatives Assessment, to just be at this central ground and space for professionals working in this field, and it's open to all. So with that, I want to thank my speakers and panelists. This was really a great webinar, especially on a topic that can take a full day of training. So thank you. Thank you for your patience for everyone participating. Thank you for joining the webinar. And for those going to Sacramento next week, we'll see you there. So thank you all and have a good afternoon.
Thanks.
Bye.